Hello, I want to ask you a question. Have you ever found yourself in a loud room trying to have a conversation but barely be able to hear what the other person is saying? Introducing all new over-ear headphones. This is not your typical noise-cancelling headphones that have been so popular in the past few years. The software uses the biological sound segregation algorithm, also known as BOSA. More on that later. Over-ear headphones aim to help people with hearing and neurological impairment. Its purpose is to focus one's attention to a stimulus while filtering out other unwanted sounds. Now, this is Hannah, and she will talk more about the algorithm.
So here is our sound seg function. First, we have sound in, and that has two different columns of data, one is the right column and the left column, which is corresponding to the right and left ears. From there, we take that data and we do such things depending on our masking orientations. Right now, we have it hard-coded to take masking orientations from -90, 0, and 90. The reason we do that is because our neurons in our minds favor certain orientations and do the filtering in our mind like that. In order to filter our algorithm, the frequencies are segregated into 64 of them. Those are our central frequencies, and these frequency ranges can be smaller or more narrow or wider depending on their importance, much like our own minds would do this. And we create spike trains, which therein go into the mask creation. And right now we have it hard-coded to mask all other sounds except for the one that's right in front of us at the 0th azimuth. So that's what would happen ideally. That's hard-coded, and yeah, output through this function is the sound right in front of us. This is the sound segregation algorithm.
That was a quick review of the software components. Now we have Ben, who will talk more about the hardware decisions that we made.
Hi everyone, I would like you to meet Gerald. We purchased Gerald in order to get an accurate understanding of how the physics of sound interacts with our device. Gerald is not part of our tech stack. On top of Gerald, you can see a headset. On each side of the headset, we have two microphones. These are USB microphones, and they take in sound from the environment into our device. The reason that we want to use USB microphones in particular is because it interacts well with our MATLAB code. So sound comes in through the microphones, and it goes into our single board computer to be processed, which is this right here. This is a Latte Panda. It is an x86 single board computer, which is capable of running MATLAB. So once sound has been processed, it comes back out into the headset for the user to hear. One of the design considerations that we're currently making is whether or not we want to keep our wired setup, or if we want to switch to Bluetooth so that we can get ahead of the game.
Ready, we'll go to white 3 now. Ready, we'll go to white 3 now.
There you have it. That is the current status of our project. We're able to process sounds and segregate unwanted noises. However, the timing of the process is not desirable at the moment, and we have to make decisions to improve that. Also, we have tested our product with different engineers who have given us valuable feedback that we will take into account when working on improvements of the project. To sum it all up, currently we're working on optimizing the software to make it faster and as close as possible to real-time processing. And as for the hardware, we want to make it more portable and comfortable for the users. Thank you, and we hope you can test our product soon. This video was brought to you by Team OVEREAR.